guys had a great week this week. We're a little bit behind, so I'm trying to get caught up a little bit. So I wanted to give you some video notes to look at. So hopefully we can zoom through this on Monday and not have to spend too much time. So these are the example notes that you'll find on the same page if you want to print them out, so that you can kind of take a look at them. The homework is also on Canvas, so you can print those two things out, or you can see me on Monday for the examples if you don't already have a copy. Alright, so these are examples. We were working with our normal curve the other day. You might want to have out the notes from the normal curve stuff that we did, your summary sheet, as we're doing this, so that it might help you a little bit. So we're going to start by drawing the normal curve up here on the sheet. So I know that this has a mean of 1500, so I'm going to start here at 1500 and I'm going to try to draw this as straight as I can. So I'm going to go up a certain height at 1500, and then I'm going to go out 300 for my standard deviation. So 1, 2, 300. So this will be my first standard deviation at 1800. And I'm going to go up about 60% of the way on that. And then over here in 1500, I'm going to go out 300 on this side. And that'll put me at 1200. So that's my other standard deviation. Okay, and I'm going to go up about that same amount. Okay. Then I'm going to go out 300 more. That puts me at 2100 over here. And I'm just going to go up a little bit on this one. And then 300 more here will put me at 900. Okay. I'm going to try to go up about that same amount. And then when I go out 3 standard deviations, I'm going to be all the way out here at 2400. And I'm going to be over here at 600. So I'm going to sketch in my normal curve. And again, you're not kind of being judged on how you sketch. That's a better one for me. Okay, and then we're going to remember that this little distance right here, I'm going to actually use the side of a Post-it note just to get this a little bit straighter. Okay, and my dot wasn't too straight to begin with. But that's our mean. Okay. So that means there's about 50% on either side. Remember that this is our other standard deviation. And this is a standard deviation. Okay. So now remember what we did on our curve. This was 68% of the data, which means that these two little chunks are both 34. Okay. This was 95% of the data. Now that means between these two little chunks that I have right here and right here, okay, I have about 27%. Yep, 27%. So that means this is going to be 13.5, and that's going to be 13.5%. And then if I go all the way out 3 standard deviations, I'm going to have 99.7% of my data. And that means that this little piece is going to be about 2.35%, and this little piece is going to be about 2.35. So all of that's from our empirical rule that we did at the beginning of class the other day. Now from here, what we're going to try to do is use that information to answer some questions. So question number 2 says, what is the probability that a student will have a score of at least 1500? Remember, our 1500 was right in the middle. That was our 50%. Okay, that was our mean. So the probability is 0.5. So when we want a probability, we want the decimal. Okay, so that's about 0.5. Okay. Question 3, what is the probability that a student will have a score between 1200 and 800? Well, 1200 to 800 is right here. So remember, that's within our 1 standard deviation. So that's 68%, or our probability would be 0.68. Okay. Between 1500 and 1800, so that's this little area right here. Okay, between 1500 and 1800. So that's 34. And this time they wanted a percent. So we're actually going to say 34%. Now, what percent of students taking the test will score above 1800? Well, above 1800 is actually this chunk of the graph. Okay? Right there, there's our 1800. Now we could add up these, that's about 15.8. Okay? Or we can look at it this way and say, okay, how much is below that? Well, we know that this is 50%, all of this, okay? And we have another 34%. So below it is 84%. So that means if we were to include absolutely everything, that would be actually 16% of our population. Now this question's kind of got a part 2 to it. It says if 150 people took the test, how many could we expect to have scored above 1800? So now we've added in an actual population, a sample, and it says how many. Well, we know it was 16%. So what we have to do is figure out what's 16% of 150 people. Okay? So to figure out what 16% of 150 people are, we are going to multiply that. So we're going to say 150 times 0.16. Note this is as a decimal. And I think that comes out to be 24 people. So when we get this little how many question, we need to remember to multiply. Okay? So that's how we figure out how many. Someone asked in class today, could you also just set up a proportion? 16 over 100 equals x over 150. Yes, you could do that too. That would be fun. Okay? All right, so all of these are finding percents and then taking them and doing something else with it. Okay? Question number 6 actually gives you a percent. It said, what score would a student need to score better than 84% of the students taking the test? So in other words, if he wants to score in the 84th percentile, what's his score got to be? Well, 50th percentile would be 1500. Okay? Well, if that's the 50th, then we can take 50 plus this 34. That's the 84 that we're looking for. Okay, so 84%, that would put us at a score of 1800. Okay, so hopefully that all makes sense with using our curve, okay, and our picture up here. Okay. Now if you look at number 7, okay, number 7 asks, what is the probability that a student will score between 1000 and 1400? Well, that's pretty tricky because 1000 is right here, okay, and 1400 is right here. So what you'll notice is it doesn't really lie on a standard deviation. It's kind of in between, and we want all of this. So we could guess and say, it's probably 30 something, but it would just be a guess. Now this is where some of the, we talked briefly about this, but some of the normal curve stuff involves calculus, and that's sort of where this comes in, and we're kind of not ready for that yet. So what we are going to do is use our calculator. We're going to let our calculator help us on this one. Okay? So there is a function on your calculator for distribution. Okay? If you are looking, I have a TI-84 plus here. Okay? And I'll show you where that is. If you're looking at the TI-84 plus, it's right over top of vars. It's under distribution. Okay? And that's what we're going to use. So we are going to use, we're going to press second and vars. Okay? All right, let me see if I can get the glare off the screen here. Okay, second and vars. And we're going to use this second one, which is normal CDF. Okay? So we're going to press normal CDF. Now, if you don't have the little helper, it's fine. You're just going to enter these things with commas in between them. Okay? So notice it says we want the lower. Well, we want scores between 1000 and 1400. So our lower is going to be 1000. Our upper is going to be the 1400. Okay? The next thing here is our mean, and our mean was 1500. We're still using the same information from above. And our standard deviation was 300. Okay? And then we're going to go ahead and hit enter and paste that in. So if you don't have the little helper, this is what it's going to look like on your screen. It's going to say normal CDF. You're going to have the low, the high, the mean, and the standard deviation. Okay. I'm going to press enter, and that tells us it's 0.32165. So that's 0.32, let's say 2, okay, for the probability. Okay. So again, what those steps were is we pressed the second key, then we pressed the vars key, which is right next to the clear. Then we chose number 2, which is normal CDF, which actually I think means cumulative distribution frequency, I think, or something like that. So normal CDF. Okay, and once we press that, then what we're going to do is we're going to put some information in. Okay, we're going to put the low value, the high value, the mean, which remember has this weird little symbol, and the standard deviation, which has got this little weird symbol. Okay? And that will give us our probability. So go ahead and try the next one, okay? And see what you get. Okay? And you can pause the video right here for a minute if you'd like while you try that. Okay? So I'm hoping that you've maybe paused it and tried it. I'm going to go ahead and do it here too. So second bar is normal CDF. The low is 1600, okay, and the high is 2000, and our mean and our standard deviation stay the same. Okay. And look again, it's 0.32. Okay. Now this time it asks for a percent, so we can say 32.2%. Okay. So notice it's the same, because basically what I did here was I went to 1600 up here, okay, which is 1 on the other side of that, and then I went from there to 2000. So it was a similar little range there, just the symmetrical on the other side. Okay. Now this one asks that how many again. So remember that's where we're gonna multiply. So we're gonna do times 300, and that's gonna give us about 96 people. Okay, 97 people if we went around. So we can say approximately 97 people. Okay. Right. Generally speaking, we round down. That's close enough that I think we're okay. Right. Okay, so let's look at this next one. What percent of students will score below 1300? Now this time, it doesn't give me a low and a high, it just says below. So we kind of have to think for a minute, okay, which one is that? If I want to go below 1300, then that means that this must be the high. So I'm going to pick 1300 right here, but then I'm just going to pick a low value, some really low value. Okay? I usually like to use 0. Okay? Right? If it said above 1300, then the 1300 would be the low, and I'd pick some really big number. And so I'm going to do second bars, normal CDF again, 0, 1300. Paste it in, and that is 25.2%. Okay. Done. Okay. So don't really have to remember those. Now, by the way, you could have used that same strategy on all of these up here. So these were really nice, and we didn't need the calculator because we have the empirical rule. Okay. But if you don't happen to remember it, you could always use the calculator. Now this last one, number 10, is very much like number 6. Okay? It has the percent, and we want the score. So all of these, okay, we had a score, and we found a percent. This one's going the other way. We're taking a percent, and we're finding a score. Okay? So to do that, anytime we do an opposite operation, like when we divide to get rid of multiplication, when we add to get rid of subtraction, those are called inverse operations, and I kind of like to remind you of that because that's where we're going to go with this one. Again, 75 is not, nicely on anything up here. That's, this is 50% and that's 84%. It's hard to tell where 75 is. So again, we're going to use the calculator. Okay, we're going to go back to that same spot. We're going to do second, okay, vars, And what you should notice is number 3 here says inverse normal. Okay. So what that does is it takes your percent and tells you what the score would be. Okay. So we're going to choose an inverse normal. Okay. The area there, where it says area, that's really your probability that you're going to put in there. So it's your percent as a decimal. Okay. It's your percent as a decimal. So that means for this one we're going to put in 0.75. Our mean was 1500. Our standard deviation was 300. Okay. And again, if you don't have the little helper, you're just going to put those in with commas. Okay. And so it's saying our score should be about 1702, okay, or a little bit higher. So maybe we want to round up and say 1703 because we can't get a decimal score. Okay. So we're doing second vars, and this time we're picking number 3, which is inverse normal. Okay, and we're putting 3 things in. We're putting our percent as a decimal. We're putting in our mean and our standard deviation. Okay, so that's the extent of those notes. I appreciate you kind of taking some time and looking at those online so that we can kind of go through those either a little bit more quickly or maybe even not at all, okay, on Monday. So please try the other homework assignment that's on the back of this sheet, okay, that's also posted on Canvas. And I will see you on Monday. Have a great weekend.